This is my presentation for the hash table assignment. I coded it in Python hash_main.py. So at top it shows you the times for the insertion of each bucket size, and then you have your options to print the whole list, search for someone, and exit. So we'll start with printing. So we can see the whole list of 1,000 registries got printed. So we're going to search, then we'll search for Ava Morgan in Arizona. Ava Morgan in Arizona. So we'll run 3 to exit, then we'll clear, then we'll Python 3 hash main.py. Oh, I did wrong. Sorry. Python 3 hash_main.py. So now we will search too. And the search is pretty easy because it's like step by step to minimize errors. So we do AZ, then Ava Morgan. Bang. Found Arizona. Ava Morgan is successfully registered. So we went over 1, 2, and now we'll just press 3 to exit the program. And then clear. Alright, and now we shall go over the code. So we have to use random to create everything. Time is just used to track the bucket size differences. These are the list of states and names that the people who registered get pulled from. So this is all mainly for the actually making the data of it. And then this runs that function to generate 1,000 states and names. And then this is our hash table class. So it runs all the way down pretty much. So first we get the table, set the number of buckets, and then this is for the data pieces like AZ Ava Morgan if there was 2 AZ Ava Morgans. So this will create lists for them to hold. This function creates the hash key. Python uses this ABS built in to do it on its own, and then we modded the bucket size. And then this is what runs to actually insert the lists. Hit the target, check if the key exists. If it does exist, it won't put it in that bucket, it will look for a new one. And this is why it takes so long in doing the 10 bucket size and the 100 bucket size, because it has to go through that 100 names in each bucket rather than just going through, just checking if the bucket is empty. So and then this is the search function. Yup. This is the target. It gets the input from the user, combines the state and the name, and searches the hash table to find it, looks for the match, returns the match. And then this is the function that prints the entire list. We have to first initialize an empty one, and for every bucket in the table, for every key, for every piece of data, essentially, we're going through and adding it to the registrations list. And then the lambda sorts it alphabetically. Another Python. Probably doesn't work in only Python, but yeah. And then this is what happens when it prints it. So it gets added to the list, and then whenever you press 1, oh shit. Whenever you press 1, where's my undo at? Oh shit. Alright, well, I'll add it back in before I turn it in. Okay. And then this is just the user interface. Oh wait, no, this is the display for the times it took for each different bucket size to take. So this is starting a timer, creates a blank table, so that way the data isn't already sorted and everything. Starts the timer, loops through, stops the timer. Then it gets the duration. Then this is the display that the user sees, where they input 1, 2, and 3 to print the list and search for names. If the user choice is 1, display the whole list. If it was 2, this is where like the drop down starts. to make it pretty easy to search for, so you don't have to. So we're not basically waiting for mistakes to happen on the user's end. You can pretty much just type it in easily by what it says. And then if that matches, print that they found it. If it doesn't match, not found. If they press 3, exit the terminal, and then if they don't press 1, 2, or 3, display to them that they need to press one of those. Alrighty, and that's everything. Thank you.